Hello and welcome! In this lecture we're going to add some logic for our game to only allow one action at a time. Okay, so here we have our game, we can move and we can also spin, but if we try taking both actions at the same time, then everything kind of breaks. So let's add some simple logic to prevent multiple actions from running at the same time. Let's go into the unit action system script. And right now down here on update, this is how we're triggering our actions. We just test for input and then trigger the actions regardless of the current state. For keeping track of if we are currently busy, let's use a simple boolean. So let's define up here a private bool and just call it isBusy. And then we can simply use it over here on the update. So just like we saw for the actions is active, over here we can test if the unit action system is busy, meaning if some action is running. If so, then let's just return. So we do not want to run any of this logic if we are currently busy. Then let's make two simple functions to set and clear the busy. So just a private void set busy, and we just set isBusy into true. And another one, private void for the clear busy, and we just set isBusy into false. Okay, two simple functions. Then when we take any of these actions, let's simply call set busy. So we set busy, take the action, set busy, and take the spin action. Okay, so let's test the code just like this. So here we are, and I'm going to try spinning and then moving right away and see if we only spin. So spin move, and yep, there you go, we only spin. So it ignored the move action because we were already busy. Okay, so far so good. Now the obvious issue is we're now resetting the busy state. So the game right now is stuck, I cannot move, I cannot spin, I can't do anything. So let's solve that. Basically what we need is to know when a certain action completes. And one way to do that is with a really nice callback delegate. Now delegates in C# are super powerful. They are how you can essentially store functions in a variable and call them later. So how we're going to use them is, for example, when we start an action, like this one, when we tell the unit to spin, in here we can pass in a reference to the clearBusy function. Then the action receives that, it does its action, and in the end it calls this callback function just like any other function, which will then run the clearBusy function and reset the isBusy state. So yep, delegates are super useful. They're pretty much just a way to store functions in a field or a parameter. All you need is a delegate type and then make a field of that type and then call that later just like any function. So let's go into the spin action script. So here we are. And you can even define delegates yourself. You just start off by normal, either making it private or public. Now naturally, if you want this delegate type to be accessible to other classes, then it does need to be public. Then we write the delegate keyword. And after that, since delegate is basically a function definition, that means you need to define it pretty much like you do any function signature. So we start off by defining the return type, so that can be a type like int or bool or anything like that. Or if you don't want any return, then we can just put void. Then the name for the delegate type, so here let's say spin complete delegate. And finally, again, just like any function signature, you open the parentheses, and here you add any arguments you want. So you can make a delegate that receives an int, can make it receive a bool object, anything you want, or you can also make it take no arguments. Okay, so this is a simple delegate definition. It's a delegate that takes no arguments and returns void. Now with this delegate definition, down here in our spin action, we can basically receive a parameter of this type. Let's call it onSpinComplete. And if we go back into the unit action system, you can see here we no longer have that error. The only requirement is that the signature for the delegate matches the one that you pass in here. So like we saw on the spin action, we made this return void and have no parameters. And if we look at the definition of the clearBusy, it is exactly that, returns void and has no parameters. If instead we tried adding something else, so let's say a function that returns an int and maybe takes in a boolean. If we have this function and we try passing it in there, then nope, we have an error. Basically, we cannot convert this signature that returns an int and takes a bool into the other one, which returns void and takes no parameters. So let's use the clearBusy instead. Also very importantly, like I said, we're passing in a delegate. So we're passing in pretty much a reference to the function. So over here, you just pass in the function name. You do not add parentheses. This would be calling the function, whereas that's not what we want. What we want is to pass in the reference to the function. So just like this. Okay, then here on the spin action, we have our spin function. We receive the delegate, and now we can just store this. So let's store this delegate just like any other variable. So store of this type, And then down here, when we receive it, let's set this one into this. Okay, we're storing the onSpin complete, and then how you call delegate is pretty much just like any other function. So over here we set is active to false, and when we do, then let's simply call our delegate. When we do, then this will essentially call back the original function that we passed. So the spin action is going to spin. When it finishes spinning, then it calls the delegate, and the delegate will essentially call the clear busy, which is going to set isBusy back into false. Also here you can note another interesting thing about delegates. You can note how the clear busy over here is defined as private, and yet when we run the delegate on the spin action, we're essentially calling that function. So we are effectively calling a private function from a different class. Usually you can only call functions directly from another class if they are public. However, if this class passes in a reference to a function that is marked as private, then the other class can indeed run the delegate regardless of the original function being public or private. So that's just an interesting way with how delegates work. Okay, so let's test and see if all of this works. Here we are, and first up, let's try doing both actions at the same time. So I'm going to very quickly spin and move, so spin move, and yep, we only got the spin. It executed the spin action, then stopped. Now if I try spinning again, and yep, it does work. Meaning we are correctly getting our callback and clearing the busy state on the unit action system. Alright, awesome. Now before we move further, just one more thing on delegates. Over here we defined our own delegate type. Now you can definitely do that, but C# also comes with some predefined delegates that can be super useful. The two that you have are action and func. They live inside system, so up here using system. And for the types that you can use, one of them is action. And you can inspect this to see the delegate definition. So this one, as you can see, is exactly what we have here. So it returns void and takes no parameters. That's an action delegate. And there are actually several versions of this action delegate to allow you to use several parameters. How you use them is with generics. Now again, if you don't know about generics, it's okay. I'm going to cover them in more detail later on in the course. So again, this default action is just an action with no parameters, but I can put angle brackets, then put an int. And now if we inspect this one, yep, there you go. This one takes the t. Again, this is generic. So what this means is that this action still returns void because it's an action, but it also has a parameter of type t, which in this case, t is int. So this delegate definition is essentially the same as something. So let's see here. So what we have here is exactly the same as this. And there are multiple of them. So for example, we can define one with int and one with bool. So again, now this one takes two arguments. The first one is int, second one is bool, and so on. So that's the action, that's the built-in delegate, which again, as you can see, has multiple versions for how many parameters you require. And the other built-in one is the func. So that one is func with a C. Now the difference between action and func is that action returns void, whereas func returns any type you want. Again, it uses generic, so it works on any type. So for example, if I put this one a func of int, if we inspect, we can see this is a delegate which returns of type t result. So that's the type in the angle brackets. So in this case, this is a function that takes in no parameters and is going to return an int. And then it has more versions for more versatility. So for example, if you wanted a delegate that takes in a string and returns a boolean, then yep, this is the delegate you would use. So this one takes of type t, so it takes a string argument and returns of type bool. Okay, so those are the built-in delegates. Pretty useful, so you don't always have to define your own. In this case, like we saw, we have our delegate returning void and taking no parameters. So this is exactly the action delegate, so we can avoid defining our delegate right in here. And instead, we can just make this of type action. So this helps simplify our code quite a bit. We don't have to define the delegate ourselves, we can just use the basic action. And down here, just make this of type action. Also, still related to delegates, another quick thing. Like we saw previously, we use the event handler, and this one, like we saw, this one is also a delegate. And its signature is just like we saw, so it returns void, takes in an object and an event args. So even if this is the first time you're hearing about delegates, chances are you've already used them. And as you can see, they are super useful and pretty easy to use. Okay, so the spin action now has the onSpin complete and everything works perfectly. Now let's just implement the same logic on the move action. But again, we want this same logic on both action types. So it makes much more sense to implement it on the base class as opposed to in every action. So let's go into our base action class and let's make a field for our action. So protected, let's make it of type action. So we need to go up here and add using system. Then for the name, just call it on action complete. Okay, so now we can go into the spin action. Instead of having on spin complete, let's get rid of that one. Instead of on spin complete, let's use the on action complete. Then we receive it when we spin, so on action complete, and we set it. Now we can do the exact same thing on the move action. So over here on the move script, let's go down into the move function. We do this, we receive something of type action, and let's add the using system. So we have the action, and here just set this one. And when the action completes, over here is active to false, and we do our callback. Alright, so that's it. Also, by the way, just in case you noticed, we do have some duplicate code here. So if you notice that, then good catch. You can see that we have on action complete over here on move action, and also the exact same thing on the spin action. Also pretty much the same thing with setting is active to true and so on. For now, we're going to leave it like this, but we're going to refactor this code quite a lot in a bit. Like this, the move action should now be completing. Let's just go into the unit action system, and up here let's solve our error. So we're calling move, and after we move, then let's pass in our delegate, which is going to be the clear busy. So the unit moves, calls clear busy, and then we can take another action. Okay, let's test. So here we are, and if I right click, yep, there you go, got a spin, the spin is done. Now if I move, yep, it moves, it's done. Now if I spin, and yep, it spins and works. Now if I try doing both at the same time, so spin move, and there you go, does a spin. Now if I do move spin, there you go, does a move. Alright, awesome, so it only takes one action whilst not busy. Okay, so in this lecture we'll learn about C# delegates, which are super useful, and we also added some logic to be able to only take one action at a time. Since we already have quite a lot of logic handling multiple actions, the next thing we need is really just a proper UI to be able to select them, so let's start building that in the next lecture.